Hey guys, Mr. Yisley here. So we are on to lesson number 26 in chapter 4, all about writing linear functions, or writing real life functions, not linear. And we're really talking about real life arithmetic sequence functions in this. And so they've given us an example here where they've given us some information and we need to figure out some information in order to do what they've asked us to do. All right, so example A, let's just read it to begin with because that's always a good place to start. It says, online bidding for a purse increases by $5 for each bid after $60, the initial bid. All right, so let's just start there with that, what they just told us. Online bidding for a purse increases by $5 for each bid. Well, if it's constantly increasing by $5, that's like a constant rate of change. But if we think about it in terms of an arithmetic sequence, right, that means that it is the common difference, right? It is the common difference. So this would be known as the common difference, which was adding 5, increasing by 5. And then it says for each bid after $60, which was the initial bid. Well, initial means first, so the first bid, right? So $60 is the start of our bid, is the first term in this arithmetic sequence, is what they're telling us. And then they've given us this chart to show the first 4 bids. And so if I look at this chart, we've got the first bid, second bid, third bid, fourth bid. Then we've got the amount of each bid, so $60, $65, $70, $75. And they're constantly increasing by 5. That's the common difference. So the first thing that they want us to do is they want us to write a function that represents the arithmetic sequence, right? So what is happening in this arithmetic sequence? Well, if you remember way back, like 2 lessons ago, we talked about that there was this formula for arithmetic sequence, right, that we could write an equation, which is what we did in lesson number 25. But we also talked about that we could write it as a function, and there was only one difference. We had this formula we used of a of n is equal to a of 1 plus parentheses n minus 1 times d, which stood for the common difference, all right? We then made this connection that this is linear, so we could write a linear function of this. And so rather than have an a of n, we could write f of n, which is equal to a of 1 plus n minus 1 times d. And they meant the exact same thing. So when they ask us to write a function, instead of using this first thing like we did when we were writing an equation, we're just going to use the second one, right? So when I go to write the equation of this, all right, I need to know 2 things. The first function, right, the first number in the arithmetic sequence, right? And then I also need to know the common difference. Well, I already know those. They gave me that information. They said that the common difference was adding 5 and the first term was $60. So I'm going to put that information in. So when I'm writing the function, I would say f of n is equal to a1, right? Well, what is a1? Well, that is $60, and I'm going to leave off the dollar sign and just say 60 plus parentheses n, I don't know what that is at this point, right? Minus 1 times the difference, which was a positive 5. So times 5. And that would be my function for this. And I could use that information if all they tell me is the place or position of the term, the n, right? I could plug that information in here and figure out what the term was in the order of the bidding. All right, so that would be how we write the function of this arithmetic sequence. The second thing they've asked us to do is to graph it, right? Well, we talked about graphing arithmetic sequences, right? We have to remember that these are ordered pairs. That deals with the n, comma, a of n idea, all right? Well, the position in the sequence is the n, so 1, 2, 3, 4. The number itself is the actual bid amount. So this is n, this is a of n, or an, excuse me. Right, so I just need to create ordered pairs out of that. So the first ordered pair is 1, 60. Second order pair, 2, 65. third order pair 3, 70, and fourth order pair 4, 75. So I've got my 4 points there. All right, so then I need to go in and I need to graph these. Well, again, things to notice, they're all positive numbers, so we need a quadrant 1 graph. All right, I notice that the ends are increasing by 1s, so that's my x-axis, right? My y-axis or my a of n axis here, or actually what we would call this is f of n, because we're dealing with functions, right? They're increasing by 5s, right? So I need to make sure that I can fit those numbers on. So I'm going to go ahead and draw my quadrant 1 graph here. And this axis right here is my n, and this one is my f of n. Right, because we're dealing with functions. If we wasn't a function, we'd call it that an term, but we're going to call it f of n. All right, I know, again, my n's are increasing by 1, so I'm going to start at 0 here and count by 1s. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now my numbers are a little bit higher here. I've got 60, 65, 70, 75. So in order to fit this all on, I'm going to choose to count by tens. And I believe that will give me enough to fit all the numbers. So I'm going to say this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. And as long as I'm counting by consistent numbers, that is completely fine. So last thing I need to go in is graph these ordered pairs. So my first ordered pair of 160 says move right 1 and up to 60. So there is my first point. Second term, 265, so right 2 and up to 65. Now that is not directly on a line, but it is directly in the middle between 70 and 60. Third term, 370, so right 3 and up to 70. And fourth term, 475, so right 4 and up to 75. Again, not directly on a line, but in the middle of 70 and 80. So I've graphed the 4 points of this arithmetic sequence of this function that they've gave me. Now I could, by extending this graph and using the pattern that's happening, I could figure out these other points. I could figure out the 13th term, I could figure out the 10th term, so on and so forth. So graphs can be helpful in that manner. The last thing that they've asked me to do is they've told me that the winning bid is $105. How many bids were there? All right, so they told me how much the winning bid was, right? But they didn't tell me where it was in the sequence. They didn't say, hey, this was the 12th bid or 15th bid or whatever bid it is. So what I need to do is I need to figure out what is that in, all right? What is the position in the sequence? That's what they're trying to help me figure out when they ask me how many bids were there. So in order to figure that out, what I need to do is I need to replace the function f of n with the number, the winning bid. So I'm going to put 105 right here, and then I'm going to set that equal to the remainder of the function I wrote, which is 60 plus n minus 1 times 5. Right? So they said the function, the winning bid, was equal to 105. Right? So what position was that? How many bids were there to get to 105? So if I set the function equal to 105, I can figure out the position. All right, well, in order to do that, I need to simplify my function. So what I want to do here first is I want to get rid of this parenthesis. I don't like parentheses, so I'm going to distribute. Now, it's not the only thing you could do, but this is a good way to start. So I'm going to distribute 5 to -1 and 5 to n. So I've got 5 times n is positive 5n, and 5 times -1 is -5. Now, I did not use the 60, so I'm going to bring that down, and I did not use the equals or 105, so I'm going to bring that down. Well, then I notice, hey, I've got like terms on this right side. I've got 60 and I've got -5, so I'm going to combine those, which makes it into 55. Now, I did not use my positive 5 in here, so I'm going to bring that down. And I did not use the equals and the 105. So now I'm into a two-step equation to solve. So first thing I need to do is I need to subtract the 55 across. So subtract 55, subtract 55. That leaves me with just the 5n by itself. And that is equal to 105 minus 55 is 50. So this is what we learned way back in chapter 1. Then I need to get the n by itself. So the 5 is multiplying the n. So I'm going to divide by 5 and divide by 5. So 5 divided by 5, that cancels. I'm left with just the n. And n is equal to 50 divided by 5 is 10. Now what that tells me is that the $105 was in the 10th position, right? It was the 10th bid. So when they ask me how many bids were there, I would say there were 10 bids. And I just realized you may not have been able to see that last part. I apologize on that. So here's the graph that we did earlier. Let me move back and I'll re-explain what we were talking about. I apologize. I forgot to move the paper up. So what I said earlier is they told us that the winning bid was $105. Then they wanted us to know how many bids were there. Well, remember n in our function stood for the position of the bid. So what we did was we set 105 equal to the function itself. So we said $105 is the end result, right? We're going to set that equal, and we can figure out the position of 105, or the bid number it was, from there. So we said 105 equal to 60 plus n minus 1 times 5, which was the function we wrote earlier. Then we simplified it down. So first we distributed the 5 and got rid of the parentheses. Then after we had done that, we combined those like terms of 60 and negative 5 to make 55. Then we were left with 105 equals 55 plus 5n, and we solved it for n. So subtracted 55 across, then divided by 5, and we figured out that n equals 10. And n stood for the position of the bid, right? That was the bid number. So we said finally at the end, how many bids were there? There were, really struggling today, there were 10 bids. All right, well, I apologize about not getting that moved up quickly enough. This is really, the graphing of the function was really similar to what you had done before, and I think you could see most of that on your graph or on the picture. And again, when they give you the end amount, the end term, right, you just set that equal to the function that you have to determine what position it was in there. All right, well, if you have any additional questions on this, please let me know. But otherwise, that is how we write those real-life functions. We solve for the information we need. So again, if you have any additional questions, just reach out. Otherwise, you have what you need to complete the chapter.